So students, let's take one example to understand all the 5 different concepts that we have learned about transforming a given linear programming problem into a standard form. Now look at my question. I'm going to read out the question first of all for you all. We have a problem of maximizing. Now as I said, if it is a problem of minimizing, you should always transform it into a maximizing type. But as I can see that it is already a maximizing type, one of the point has been already saved, isn't it? One of the work has been saved. Out of the 5 steps that I've already told you, the first step was the problem should always be a maximizing type. So since it's already a maximizing type, less things to worry about. Next thing is we have to transform all the inequations into equations using the slack and the surplus variables, isn't it? Slack variable and surplus variable. Whenever it is a less than type, we put up a slack variable, we add a slack variable. When it is a greater than type, we subtract a surplus variable. So the next thing I want to check whether my inequations, do I have any inequations? So yes, there are inequations, first, second and third. There are 3 inequations you can observe, and there is an equality. The fourth one is an equality. So equation, we need not think about it, isn't it? Because it is already an equality. So we have again one less thing to worry about. So this is an equality. So it need not be, what you can say, changed or transformed. It will remain as it is. But these 3 inequations has to be transformed into equalities. Now the next point I should observe, is there any inequation whose right hand side is negative? Because I should always remember the third point was telling me that the right hand side should be non-negative. It can be positive, it can be 0, but it cannot have a negative sign. So when I observe the 3 inequations, the third inequation contains a negative sign. That means I will have to transform this inequation, this negative sign, to a positive sign. And how can it be achieved? Multiplying this with a negative sign. So I have this inequation. I'm going to transform this, isn't it, the negative sign. I'm going to change it to the positive sign. So what should I do? I should multiply both sides with a negative sign. Multiplying both sides with a negative sign will change this less than type to a greater than type, isn't it? So I'm going to write minus 3x1 minus of 4x3, isn't it? And then greater than or equal to, it now becomes 5. So the right hand side should always and always be what? It should be a positive sign. It should always have a positive sign. So to change to a positive sign, what I've done is multiply both sides with a negative sign, and the left hand side, when it is multiplied with a negative sign, and the right hand side multiplied with a negative sign, the inequality from less than has changed into greater than. So that's one point you should always keep in mind. Nothing has to be done to the equality, isn't it? No changes to the equality, it will remain as it is. Come ahead. How many variables are involved? How many decision variables are involved here? There are 3 decision variables. X1 is there, X2 is there, X3 is there. But did you observe X1, X2, he is telling it is greater than or equal to 0. But what about X3? It is unrestricted, isn't it? That means you have to change X3 as X31 minus X32, and then tell that X31 and X32 are both greater than or equal to 0. So the first point, question should always be a maximizing type. This was already a maximizing type, one less thing to worry about. Next is the subjective functions. The right hand side should always be positive. So there was one subjective function which had a negative sign on the right hand side. I have transformed it to a positive sign by multiplying both the sides with the negative sign. It transformed the inequality sign, isn't it? It was less than type initially, it now became a greater than type. I am going to transform them into equalities by using the slack and the surplus variable. Less than type, slack variable; greater than type, surplus variable. Nothing to worry about the equality sign. Further you go, you can see that there is an unrestricted variable. Transform the unrestricted variable. X3 it was here, so X31 minus X32, and both X31 and X32 are taken greater than or equal to 0. So these are the conditions that I have applied to this particular question, and now I'm going to write the standard form. So how many inequations are there? So there are 3 inequations, isn't it? There are 3 inequations. That means I will need 3 slack or surplus variables depending on the inequalities. Come to the first one. So the subjective function now becomes 3x1 minus of 2x2. Since this is the first inequation and there are three variables involved, so I'm going to write plus 0x3. Now this is very important. How many variables are involved? There are three decision variables. So x1 is there, x2 is there, but x3 was not present in the first inequation. So I have put up a variable x3. Now since it's a less than or equal to type, I'm going to add a slack variable. So let's add plus s1. So that's my first slack variable, isn't it? Because it was less than type. So plus s1. There are two more inequations, isn't it? Two more inequations which I want to transform. So I'm going to write plus 0s2 and 0s3. So note down the things very properly. There were three inequations I had. There is s1, there is s2 and there is s3. Now since there are three inequations, hence I have put up three variables, slack and the surplus variables. So s1, s2 and s3. So the first inequation s1. Then for the second inequation I'm going to put s2. The third inequation I'll put s3. But writing the inequation into an equation, all variables should be included. x3 was not present, so I've written 0x3. Since this is the first inequation, I've written plus s1. s2 and s3 are going to come in the next two inequations. So I've written 0s2 and 0s3 and then equal to 6. So that's my first inequation transformed into an equality. Let's move on to the second one. The second one is 2x1 plus 3x2. So I'm going to write it 2x1 plus 3x2 plus 5x3 and 0s1, isn't it? So s1 was the slack variable used for the first one. So here it is 0s1. This is a greater than or equal to type inequation. So it's a greater than or equal to type. I should use a surplus variable here. So I'm going to write minus s2. So has the change been observed here? I've written minus s2 because this is a greater than or equal to type inequation. So minus s2 and then 0s3 is equal to 12. That's my second inequation, isn't it? The third one now comes out to be 3x1 plus 4x3 less than or equal to minus 5, but I have transformed into greater or equal to plus 5. So now it is again a greater than or equal to type. That means I should be writing minus 3x1. There is no x2 variable here, so I'll write plus 0x2 and then minus of 4x3 plus 0s1 plus 0s2 and minus s3, and it is equal to, we have plus 5. That was my third inequation. The fourth one is an equation, isn't it? So this equation now needs to be transformed. So I'm going to write 2x1 plus 5x2. There is no x3, so I write 0x3. It does not need any kind of slack or surplus variable. So 0s1, 0s2, 0s3 is equal to 10. So these are the four subjective functions. The inequations I had previously have been now transformed into equations. Now one very important thing I want to note down here is that x3 was an unrestricted variable. So I will find out everywhere this x3 and I'm going to transform this x3 into x31 minus x32. That means in my next step I'm going to write these subjective functions as 3x1. Now this step could have been done here itself, but to just avoid the confusion, because we are going to take only one question to understand this, so what I have done is I have broken the solution into two steps. Again I am telling x3 could have been written directly in this step itself. If you want, you can write x3 directly, x31 minus x32 over here itself. But for simplicity purpose, for the sake of simplicity, I have taken it in the next step. So I can write 3x1 minus 2x2 plus 0 x31 minus x32 plus s1 plus 0 s2 plus s3 equal to 6. Then I write 2x1 plus 3x2 plus 5 x31 minus x32 plus 0 s1. Then there is minus of s2 plus 0 s3 is equal to 12. Then you write minus 3x1 plus 0 x2 minus of 4 x31 minus x32 plus 0 s1 plus 0 s2 minus s3 equal to 5. And the final one was 2x1 plus 5x2 plus 0 x31 minus x32 plus 0s1, 0s2 and 0s3 equal to 10. And finally, you should add your non-negativity constraints. So the non-negativity constraints are x1, x2, x3, s1, s2 and s3. Everybody and x3 has been transformed into what? x3 1 and x3 2, and then s1, s2 and s3, they are all greater than or equal to 0. And finally you can write your objective function. So the objective function can be written as, it was maximize z is equal to 2x1 plus 3x2 plus 5. x3 is written as x31 minus x32, then plus 0s1, 0s2 and 0s3. So students, this is how we transform a given linear programming problem into a standard form. Now note down here, I had a maximizing equation. Suppose if I had a minimizing equation, we're going to transform slightly. In the same question, we'll do a minimizing problem. So if I had a minimize problem, minimize, he's telling minimize z is equal to 2x1 plus 3x2 plus 5x3. So how much change I will be observing? So this minimizing will transform into maximizing, isn't it? Maximizing type. I'll write z1 or z dash, you can say. It is minus of z. So that becomes minus of 2x1, minus of 3x2, minus of 5x3. So if I want to write here, I'll write maximize z dash is equal to minus of 2x1, minus of 3x2, minus of 5x31 minus x32 plus 0s1 plus 0s2 plus 0s3. So I have covered all the 5 concepts that were needed to transform a given linear programming into a standard form. So these are all steps you want to remember. So whatever kind of question comes now, you will be able to solve them. I strongly recommend the way I started explaining all these things. At the same time, you should keep on writing these things in your notebook so that it becomes very well versed with you. So students, this is where I'm going to leave you. You try to solve more questions, and as I always tell, that the exam papers are your best source of questions. So make sure that you solve more and more questions. We will be meeting in our next lecture, in our next session, and there will be learning something called as degenerate solutions, degenerate and non-degenerate solutions. And there will be one more session in which we will take problems on simplex method. So there are 2 more sessions that we want to again conduct after this. In one of the session we'll be understanding what is degenerate and non-degenerate solution. In one of the lectures we are going to understand what is simplex method. So make sure you keep watching all these videos, you develop all your concepts. I thank you all for watching the video. Have a great day ahead.